In this next problem, what we have to do is recognize there's more factoring that's going to be happening at step 0. We're going to need to actually factor the denominator to identify those points of discontinuities. So I want to recognize there's a GCF of 3. And so when I divide out my 3, this will be x squared minus 75 divided by 3 is 25. And so from there, I want to recognize there are difference of squares factoring that can be done. And so this denominator is going to be 3 times x plus 5 times x minus 5. So I factored out my 3, and then I rewrote it, fully factored form, so that I can identify the points of discontinuities. Step 0 just being there as the means to the points of discontinuities. The points of discontinuities happen when the denominator is equal to 0. So I set each factor equal to 0. So I set x plus 5 equal to 0 and x minus 5 equal to 0. And I solve each of those. I'll get x equals negative 5 from the first one and x equals positive 5 from that second one. Now, it's very important to keep underneath these which factor produced which point of discontinuity, because if I get to the end and something cancels, I want to know which one is canceling, because that will define which one of these is which type of discontinuity, whether it be a horizontal asymptote or a vertical asymptote or a hole. Now, I will have a lot of students that ask me about this 3, and they'll say, well, Mr. Duggar, isn't 3 a point of discontinuity? Well, no, because 3 is just multiplied here. So if you're using the zero product property, say, oh, well, 3, you set that equal to 0 if you wanted to carry out the point of discount or carry out the zero product property all the way. That's impossible. 3 can't be 0. So that doesn't make sense. Technically, what really happens is when you set it equal to 0, you divide by 3 and it disappears. So please don't call 3 an additional point of discontinuity, or by 3, I mean any coefficient that's out in front does not cause an additional point of discontinuity. So now we've identified our points of discontinuity. We are now ready for step 2 to factor the numerator. This time, no factor process for the numerator. And so 2x minus 9 just comes on over. So I have now factored my rational function. My issue I'm looking for is anything that is 2x plus 9 on the top and the bottom. Well, on the bottom, I don't have a common binomial factor, so everything is just remaining. So both of these are not holes. They are both vertical asymptotes. And by these, I mean my 2 points of discontinuities are classified as vertical asymptotes. So I have 2 vertical asymptotes this time, 2 VAs. I have x equals negative 5 and x equals positive 5. So on the graph, if I was to graph it, which is what we're going to do eventually, at positive 5 and at negative 5, I would draw a vertical dashed line to represent 2 boundaries for which the graph cannot cross, which will cause the graph to take off to positive or negative infinity as you approach those lines from left or right.